Okay, hi everyone. Today I am going to do another episode of our MPS streams. So while last time we built some type system for our language, we added a couple of more expressions. Essentially a bunch of binary expressions. And today we will take a look at constraints, variable references, things like that. How to build these kind of things and what to keep in mind when doing this. So you can see the language we built last time, or the current state of our language here. Yeah, it supports currently variables with names and optional types. So variables can get types here, and then we can make this an integer, for instance. There's also basic checking going on. So if we select a string here and we initialize the variable with an integer, there's checking going on. Apart from that, we have some expressions that allow us to compare values. In this case here, greater equals lower 2, etc. Yeah. So this is how the language currently looks like. And today I'm going to do two things. So the first thing is we will build our first language extension, so to say. So we will build a second language in the same project. And the language will contribute or reuse parts of the basic language that we already defined. But it will also add to a project that is already using our basic language. And then afterwards, we will take a look at what we can do with our variables, because at the moment they are pretty much useless. You can create variables, but you can't reference them, right? So here in code completion menu, you see there's no way to actually reference anything. So if I type CX here, nothing happens. It still stays red. So this is something we will address after that. Okay, so let's build our first language that extends our basic language. So the idea here is we build a very simplistic extension to it. Basically a test language that allows us to define test cases. But instead of just adding new concepts to our basic language, I am going to add these concepts in a separate language, so that we separate the basics of our expression language from the aspect of testing. So if you do not use the testing language, you also don't see anything of the testing, any of the testing related concepts in code completion. Okay, so first thing I do is I create a new language in the project, and I call it test language. This, I don't select any of the other checkboxes. I don't want a runtime solution, and I also don't want a sandbox because we already have a sandbox. Afterwards, MPS asks us if it should add the files to Git, and yes, I want to do this now. If you don't do it at this point, we can also do that later, so it doesn't really matter what you do here, but I just want to have them as part of the Git index already. So as usual, MPS gives us an empty language with no structure, no editor, etc., but it has already created the basic language aspects for us. So let's go here and create a new concept, and I will create a concept called test suite. The concept does not extend anything. it also it implements INamed concept because our test suites should have a name. And we can make I would like to make the test suite a root node. So that means we can define them next to our workbooks. Because I don't want to put test suites into the workbook. And now the next thing I would like to do is the tests. So the test suite should contain multiple test cases. So let's create multiple tests. Yeah, let's name them test case. We also don't extend any other concept here, but we also implement INamed concept because we want to give those concepts a name, those instances a name. So our tests have names as well. So let's go back to the test suite and add a new child role, tests, and this is a list of test cases like this. Okay, now we need an editor for this. Let's keep it simple. Concept editor. Let's do a particular collection here. Let's add a horizontal list. And just call it test suite. And then the name. Like this. So similar to the workbook we defined in the previous streams. And then I would like to have an empty line and then add the actual tests here. And our test cases, they also need an editor, but before that, they need content. So we want to be able to write code in the individual test cases. So what we need to do is we need to define what we can actually put in a test case. And what I want to do is I essentially want to allow the user to write similar programs, similar code than in the normal workbook. But I would also like to add some additional statements to Assert. So how to do this? So let's get back to the test case. So statements. So what I would like to do is I would like to have a list of statements just like in the workbook. So if we go to our workbook here, we can take a look at it and we can see that there's content. And the content is a list of B statement. First thing I noticed, I wasn't consistent with the naming here. So let's also prefix the test case and the test suite with our capital B, which we introduced with the console refactoring that I showed last time. Okay, so back to the test case. Yeah. So the test case should contain a list of statements. So if we type a B statement here, nothing shows up in code completion. So what we need to do is we need to import our statements. And since they are located in the basic language, what we need to do is we need to import the structure definition of our language. We can do this by pressing Command R or Control R if you're on Windows. And then just search for B statement, press Enter. And our MPS wants to add the import automatically, and we would like to do that. Okay, so let's also call this content, because it's the content of the test case, and then make this a list from 0 to n. Now let's give our test case an editor. In this case, I'm going for an indent layout, and you will see in a minute why. So let's first do a collection here, and have a static editor cell here with the static text test and then show the name. Then I would like to have an opening curly bracket. And then I would like to show the content, which is the statements. And then another closing curly bracket. Now I don't want to show all of this on a single line. So what I need to do is we need some line breaks. And the indent layout supports also line breaks and, as the name suggests, indents. So you can indent the content on these lines. So let's first add a new line here. So what we want to do is we want to add a new line. Oh no, not here. We would like to add a new line here. So after the curly bracket, we would like to have an inline, a line break. And now the contents should be indented by 1. And the closing curly bracket is also on a new line, but it has no indent. So all the statements of a test case are now a bit to the right when we do this. So next thing is what I would like to do is the children here should also, let's build this and take a look how it looks. Oh, we do too much here. Okay. So now if we right click here, we still don't see the test case showing up here. We just see the workbook in the new menu of our sandbox. So what we need to do here is we need to use our new test language. So test.language, let's import this as a used language, press OK. And now new menu here has 2 entries. The workbook is before and the test suite here. So now let's create a test suite, my tests, and a test case. Some name. And now what you can see is that nothing really happens here. So if I press enter, the cursor goes to the right. But I want to have the statements on single line. So let's go back to the statement, to the test case editor here. What we can do is we can invoke the intentions menu here, and then we can see that there's an entry at new line for children. And I think this is what we want to do. So let's take a look. Yeah. So the intention is setting a style here, which is indent layout new line children to true. And this style then applies, when the style is applied, it creates these new lines here for each of the statements that we create. So now if I press enter, each new line here is an empty statement, which is our empty line concept. We should also be able to, we are not. Okay, code completion is okay. For some reason we can't instantiate anything here. So can type, nothing happens. Let's take a look at the true is here. So I selected the wrong thing from the code completion menu. So what you can see is that I selected empty statement here, and it should be the statement and not the empty line. So we don't want to have test cases that only contain empty lines. We want test cases that can contain any statement. Let's rebuild this. Go back to our test case. And now if we press Control Space, we can see that we can define variables 1 plus 3. So the same as in the workbook, just by reusing the same concepts as we would do in the workbook before. So now all of our statements that are valid in a workbook are also valid in a test case. And if we press enter here, yeah, this is what I was expecting. So similar to what happened with the workbook at the very beginning is that when you press enter, MPS will not create an empty line, but just some B statement here, which is an abstract concept, so it's not allowed to instantiate. And the fix is, as usual, to go to the editor here of our test case, go to the contents, and then in the inspector down here on the right side, we need to specify the element factory. And as we did with the workbook, we just create new empty statements by default. So when the user presses enter, we just create empty statements. So like this, we now have empty lines in our test case. Okay, so next thing. Our test cases at the moment, so we can also define multiple test cases in a single test suite. Other name and same things work here as well. This. Okay. So, okay, until now, the test language is pretty much not adding much. So, what I would like to add is the ability to assert something. So what we need here is another concept, and it's an assert statement. The assert statement, and it's extending the B statement. So that means at all places where we could use a B statement, we can also insert an assert statement. MPS now gives us an error here, which means which claims that we are extending the statement concept, but our language is not extending the basic language. So what to do here is that we can press Alt Enter, and then MPS presents us an intention. And the intention here to fix the error is add language, basic language to extended languages. And if we press this, MPS has now done something, and I will show you in a second what. So when we go to the module properties of our language, by right-clicking on the test language and then go to module properties, this dialog opens. And if we take a look at the dependencies tab here, MPS has added this entry for us, which has a different scope than the default one. So before we were only using concepts from our basic language, but we were not adding any new subconcepts, etc. What that means is that that the scope here is enough to just be default. And when it's default, you can reference things from the other module here, but you can't extend them. And we now and MPS has now added a second entry here with the scope extends. We can also remove the first one if we want to, but I will leave them in for now. And that means when the scope is extends, we are also allowed to extend concepts from the other language. Let's go back to the assert statement. The assert statement has no children at the moment. So what we want here is that the assert statement can have an expression which is used as the value that we assert on. What we need here is then a new child. I will just call it expression, and it's of type B expression, like this. And the expression is not optional, so we need to set it to 1 here. Now let's take a look at the editor. Still need an editor for this. And I think the editor is pretty simple. Let's use a horizontal collection. Then the text assert, and then the expression we assert on. Let's build this. Let's go to the test case here. Oh, I forgot one thing, and that's the alias. At the moment, the assert statement in the code completion menu here show up as B assert statement as the matching text here. So let's change that. Let's go to the assert statement and give it a alias assert, and let's rebuild. Now in our tests we can type assert, and it's automatically transformed into an assert statement. And also add condition here, 21 greater 1 for instance, that works. And also use string here. So right now there is no checking going on because we haven't done anything for this yet. Okay. So let's first fix the checking here. What we can assert on is only Boolean expressions, which we can ensure with the type system, just like we did with the binary expressions in the last episodes. We define an inference rule, and then we add a type rule here. So we want to assert that the type of expression is of type Boolean. Okay, we are missing our Boolean type at the moment. What to do here is just press Command R, search for B Boolean, or BBO is already enough, and then MPS substitutes it. Select this, and now it's available in code completion menu. What we needed to do is we needed to import the structure definition of our language into the type system aspect of the test language. So the basic language defines the Boolean type, and we want to add it to the test language here. Let's rebuild and go back to the tests. And when I press F5 to re-evaluate the type system, we get the error message here that there are incompatible types between Boolean and string. That means in the cases where the user is not using a Boolean expression here, we get type system errors. And at the case where we are using a Boolean expression, it works. Okay, let's go back to the workbook and see what happens here. So can I add an assert to the workbook? Yes, I can. Since our sandbox solution is using both of the languages, the basic language and the test language, what happens is that the new assert statement is available everywhere where a statement is expected, since it's a subconcept of our statement. what we need to do is we need to somehow constrain this. I don't want the user to write asserts into a normal workbook. What I want the user to do is to write assert statements into the test cases and not into a normal workbook. What we can do here is we can create a constraint for the concept assert statement. And in this assert statement, we can define various constraints for the assert statement here. So one is can be child, can be parent, can be ancestor. And in this case, what we want to check is we want to only permit the statement when we are in a test case. We can do this by writing a very simple constraint. So the constraint basically looks like when the parent is a test case, then the assert statement is allowed, and in other cases it's not allowed. And the can be child constraint already has a parameter here, parent node, which is the node that is the direct parent of our assert statement, or that will be the direct parent of our assert statement when it's inserted into the AST. What we do here is we say parent node is instance of, so we check what is the concept of the parent node, and we expect that the parent node is a B test case. If we rebuild this and we go to the test case and type assert, and it still works. We go to the workbook and we type assert here, nothing happens. What's MPS doing? It's behind the scenes, it's evaluating the constraints that we wrote for the assert statement concept, and is then evaluating if the concept is allowed in the context or not. And in this case, we only allow it in the test cases. Okay. Next thing. So what we see here is that can be child, can be parent, or can be ancestor are usable for constraining the context where you can actually apply your concepts to. Even if your language definition is pretty generic, in certain contexts you might not want to allow your concepts, and then you can use can be child, can be parent to do this. Obviously, this is a very simple case. You can write arbitrary code here and even assert over the role in which the concept is instantiated. So if we had a test case here as the parent, and the test case would have two different child roles here, not only content but also a different one, and both of them would take statements. We could, for instance, check in the constraint of our assert statement that we are in the right role, in this case the content role, for instance. That would look like this. So there's a link expression here. This and this. So what we compare here is if the link that we get here, which is the which MPS calls a containment link or a child role, is now the child role here of the test case. And if this is not the case, constraint would evaluate to false. I'm not doing anything more here because it gets quite advanced very quickly. We need to know how certain things in MPS work with respect to containment links and instantiation. Well, this is something for later. Okay. We had a look at the basic can be parent and can be ancestor constraint. So let's introduce some more use cases for constraints. As I said earlier, at the moment, variables are pretty useless because you cannot reference them. Next step here would be to introduce variable references into our language, which allow us to reference the variables in expressions. Something like this: x plus y. X is a Boolean, so it makes a little sense to do that, but y here, for instance, and z, something like this. At the moment, MPS has no idea what these what this is, because we have no concept in our language to represent the reference to a variable. Let's change that. I'm not going to add this to the test language because it's generic and is part of our normal language definition. What I'm going to do is I'm going to add a new expression here. And in the basic language expressions, I'm going to create a new variable reference. And it's an expression, so expression, because we want to use it everywhere where expressions are allowed. We don't need an alias here, and I will show you in a minute why. And as the name suggests, we need a reference here, so we don't have containment or properties. There's no properties to define here. You could obviously think of, I mean, a naive approach would be that you think of we would need to store the name of the variable that we want to reference or something on the variable reference, but we don't need to do this. MPS has first-class references. What we do is what we don't do is resolving it by name every time we would encounter the variable reference. We want to really tell MPS that a variable reference has a pointer, so to speak, to the variable it's referencing to. And MPS calls this references. What we do here is our variable reference gets a new reference child, which I call variable. This, and it's pointing to our B variable here. And it's also not optional because all of our variable references should point to one variable, and it makes no sense to create a variable reference in the AST that does not point to any variable. So like this. Okay, now our variable reference contains a single reference to a variable. And we can also define an editor for it. Concept editor for variable reference. And when we hit Control Space here, just like children, we can select references from the code completion menu. But there's one thing that is different here. If we go to an editor definition for something that has children, the test suite, for instance, here in the editor, oh no, this is also multiple. Let's go to the variable itself. Yeah. Because this has a value and a type. So those are children and not references. And in the editor definition, what happens here is that you are able to select the complete type or the complete value here as a thing to show in the editor. While if we go to our variable reference here, if we press Control Space, you can see that only the variable with the arrow afterwards shows up. And this is because we need to decide what part of the variable or of the node that we are referencing to in the AST, so the variable, where we are actually referencing to. And if we select the variable here, we need to basically select what aspect of the variable we want to show in case a reference is created, or is shown to the user. Let's put it like this. This has nothing to do with creation. And what I want like to show is the name of the variable that we are pointing to. So the variable reference is basically represented by showing the name of the variable it's pointing to. Let's build this. Okay, and let's go back to our workbook and now see what happens. So in code completion, we can see that now there are some more entries. In this case, for instance, A shows up, which is our variable that we are declaring at the moment. C shows up, which is the variable here on top. X, Z, etc. So some variables show up here. You can also select this from the code completion menu. For instance, C. And then we can also continue typing C plus Y. Like this. We get a warning here that a when concrete block is never concrete. We will take a look at that in a moment, because there's also something going on here which we don't want, because we don't have types at the moment. So this is the warning because we have not defined any type system for our variable references yet. But what you can see is we can now reference existing variables. But what you also see is that there's quite a lot of stuff in code completion menu here which looks strange. So there's some var. Where's this coming from? So let's select it. And if we do command click here, MPS follows the reference. What we can see here is that that this reference is pointing to a variable defined in some other test case. Right now, our variable references have absolutely no scoping. That means the variable references can point to any variable that you defined in the same model by default. And we will take a look at changing that. It also means, let's first change that. And let's take a look at the type systems. Let's take a look at the type system first, because I think this is the easiest to fix. If we go to our variable reference, we can see that it's missing the type system aspect entirely. How do we define types for concepts? We create inference rules. The inference rule for the variable reference, how would it look like? In our case here, the type of the variable reference from the type system perspective should be the same as the type for the variable that we are pointing to. So for instance, if I reference Z here, then Z should be this reference here should have the type integer. At the moment, if we try to open the type inspector, we only get the info message that there is no type associated with our expression here. The inference rule, the type of the variable reference here is calculated by adding an equation into the type system, which I explained in the last episode in detail how this works, so that you can add in a declarative way new equations to the type system. You don't need to implement this in an imperative way. You can just add additional equations how to calculate the types of your language. And the type of the variable reference is calculated by the type of the variable that we are actually pointing to. What to do is here, we can just tell MPS that we want to have an equation in the type system. That means the type of a variable reference is calculated by calculating the type of the variable. What we do here is we dispatch, or we just declare that there is a way to calculate the type of a variable. And if we go to our variable declaration here, and then take a look at the type system of it, we can see that the type system here is already implemented. So we told MPS already how to calculate the type of a variable. And now we are basically reusing the logic here and telling MPS, yeah, we have a variable reference, and the type of this variable reference here, just take the existing rules how to calculate the type for the variable that we are pointing to. Let's make our changes and go back to the workbook here. And I now press F5. The warning here goes away. And if we inspect the types with the type inspector here, the type explorer, we can see that now Z has the type int. And the Z is declared as a variable of type int up here. We can also check what the type of C is. We have not specified the type of C explicitly, so it's inferred from the initializer. And it's also integer in this case, because it's just adding and subtracting a bunch of numbers. And our type system for numbers is pretty simplistic at the moment. It simply assumes all numbers are integers because we have no way to define floating points, etc. What we did is now we reused the type system for the variables and basically just used it in the variable references. Next thing we want to do is we want to constrain what you can actually reference. In this case, for a workbook here, for instance, we only want to allow the variables declared in the same workbook to show up in the code completion menu. And this is done with scopes in MPS. And scopes are also defined in the constraint aspect of a concept. If we go to the variable reference here, and the variable reference at the moment has no constraint aspect, so it's basically applicable everywhere where an expression is applicable. But what MPS is doing for us behind the scenes is that it's handling our variable reference as a smart reference. And a smart reference in terms of MPS is a reference or is a concept that only has a single reference. And that means MPS will only include the variable reference here in the code completion menu when it finds valid targets for the variable. And this works because we have no alias here, so it does not. That's why it's not showing up in the code completion menu when there is no valid reference targets. At the moment, of course, there are a lot of valid reference targets. Even if we go to, if we would delete everything here and open the code completion menu, we still see that there's some var and x defined in the tests, which we obviously don't want to have in here. That's because MPS automatically includes these things into the context assistant when there is a valid reference target for the variable reference. How can we fix that? Let me first undo the changes here so that we get back to our initial working state. Okay. What to do here is that we need to define a scope, and this is done in the constraint aspect. First of all, create a constraint aspect for the variable reference. And then we don't want to add can be child, can be parent, or ancestor constraint. We also have no properties on our variable reference, so there's nothing we want to add there. But there's another block here called referent constraints, and this is the thing where we want to work on today. If we press enter here, MPS creates this this link scope definition for us. And if we press Control Space here, the code completion menu shows up all the references that we have on the variable reference. And since we only have one, it only gives us a single variable here. And now there are two things here that you can define. One is a referent set handler, which is code that is executed when somebody is selecting the reference target from the code completion menu. We don't want to do anything with that, but what we want to do is we want to influence the scope. And we can do this at the scope block here. When we press Control Space, MPS shows two entries here. One is inherit. We will take a look at that maybe later. So let's choose the straightforward implementation for now. And the straightforward implementation here is reference scope. When we select this, the code the element that we get in the editor is a function that takes a bunch of arguments, reference node, context node, containment link, etc., and should return a scope. Yeah. And in the inspector, we also get some documentation and comments what these individual arguments are and what is passed in there. Okay. And these arguments are the reference node that contains the reference links as the documentation. Let me move the camera to a position where you can actually read it. So let's put it on top. Okay. Down here in the inspector, there are the parameters explained. There's a reference node that contains the reference, and then there's also a big fat red comment here. Optional may not exist yet. In this case, the reference is being created. That means reference node is actually in our case, is the variable reference. The node that contains the reference. And in this warning here means in the case where you press Control Space and the code completion menu is showing up, this variable reference might not, well, in this case, definitely does not exist. This is why this node can be null, so it's nullable, and this is why the warning here appears in the inspector. Second parameter here is context node, closest not null node, not null context node. If the reference node exists, then context node is the same as the reference node. What does it mean? In case where we press Control Space here and there is no variable reference created in the AST yet, it means it will pass in the nearest not null node. In this case, there would be the parent, so the plus expression here. That node allows us to access the context where we are currently in the AST. And then there's a bunch of other parameters like containment link, which is the link where we are created in. And the position, which is the index, and the link target. We also don't care about these 3 parameters yet. What we want to do is we want to get all the variable declarations in the same workbook when we press Control Space. All variables defined in the same workbook are valid reference targets for our variable reference here. How can we do this? As the reference node might not exist yet, the only thing we can access to get the context is the context node. Okay. And let's assume we are here. So there's a plus as the parent. And then we want to create a variable reference here to the variable C. What we need to do is, from this position here in the AST, we need to go all the way up to the workbook and then get all the variables defined in the workbook. We can do this by using the asModel API, or it's called asModel API, and there are language extensions to Java inside of MPS to easily work with this. Let's take the context node, and then the API allows us to walk the AST upwards to an ancestor of the context node. And what we are looking for is the workbook. The workbook. This tells what we are doing here is going from the context node up to the very top until we reach a workbook. And then from the workbook, we need to look into the content. All the variables here in the workbook are part of the content of the workbook. And then what we need to do is we want to get all content that is a variable declaration. We don't care for expression statements or empty lines or something. This is not what we are interested in. We are only interested in the variables defined at the same workbook. And what we do here is we filter the content to a given concept. We are only interested in the variables. Now, this is obviously not a scope. So what MPS complains here is, in this case, so let me move the camera back to the lower position so that you can see that better. What you can see here is an error message that MPS complains that a sequence of node B variable is not a scope because this method requires us to return a scope. And we can do this by, we can fix this by returning an actual scope. MPS ships with several scope implementations by default. Are not imported yet. And let's search for different scope here. Okay, so there is a concept in MPS called list scope, which allows us to initialize a scope from a list of possible targets. And we can import that by pressing Command R, typing list scope, and then selecting the list scope class from the code completion menu. And this is now like the import statement you would do in Java, just that you don't see the import statements here. The import was done behind the scenes. And now the code completion menu contains a bunch of new scopes here. And we are looking for a list scope. And the list scope has some static methods to construct it from a sequence of elements. And in this case, we have named elements because our variables have names. What we do is we want to create a list scope from named elements. I'm copying the expression to select the variable declarations out of the workbook and paste it as a parameter. And now the error is gone. MPS is happy, and we can build our language again. Do that. Go back to the workbook here. And now if we open the context assistant here, what we can see here is that now all the other entries from the code completion menu, for instance, the sum var, is gone. And also sum var here complains that the reference to the variable is out of search scope. We have now implemented the first scoping for our language, which allows us to select variables that are defined in the same workbook as the expression we are currently in. So you cannot escape the scope from a single workbook here anymore. We can only reference variables defined in the very same workbook. Okay, but now what happens if I go to our test cases and I want to define a variable x here, and now I want to define a variable y. And here I would like to say x plus 10. But there's no x in code completion menu. What happened is that our constraint here is very specific to the context. It only works if we have if our variable reference is contained if you want to add a variable reference in a workbook. It does not work in any other context where we are able to define variables at the moment, because our scope is implemented in a very hard-coded way. The only way to get the list of available variables in the current scope is by walking up the AST and going to the workbook and then selecting the contents of it. But in the case of where we are in tests, there's no workbook involved here. And also the structure is a bit different. While our workbook is like the top level concept here, and it contains all the content directly, our tests look a bit different. We have multiple test cases in the same test suite. And in each of the test cases, I can define a variable. And I would like to be able to reference only variables defined in the same test case here in this example, but not from other test cases or all the variables defined in the same test suite. This is not what I want. I want to access the variables defined in the same test case. How can we do that? We need a way to somehow get all the statements in the current context, right? And the context can be different. So in one case, the context is the workbook. And in the other case, the context is the test case. that means we somehow need to abstract the fact away that we have either a workbook or a test case. And while there are multiple ways of doing this in MPS, one way of doing that is, for instance, that we define an interface. And then all concepts that provide a scope of statements could implement this interface, and the interface has a method that returns all the statements. We could do that. If we create a new interface, let's call it statement container. This. And now one thing we can do is we can go here and the most obvious thing we could do is we can just go here and say everything that is a statement container has a child content, and this is of type B statement, which means it basically it has the same child entry here as our workbook, right? So the workbook has a child content which contains statement, and our test case here also has a role content, and this is of type statement. But if we would do this, if we would do this now with a very naive way, we can actually do that. Okay, so we have our B statement container here, and now we want to change our workbook to use the B statement container interface. First thing is obviously to implement the interface here. On the workbook, besides the INAME concept, we also implement the statement container now. And what happens now is that MPS complains the B statement container has already declared something called content. Which we cannot easily just override here. And as we would like to reuse the definition on the statement container, we could just delete the child here. Now our editor will be broken, right? So because we have deleted the content on the workbook, and we would need to point this to the content defined on the interface. If we open code completion here, we can also see that that we get the children defined on the interface and can select the content role just as before, and now build the language. And if we now go to our workbook, we can see everything is gone that we wrote before, and there's errors. And what happened is that in the old concept definition that we had of our workbook, we defined children to be part of the workbook directly. And MPS calls these things containment links or child roles. And this child role does not only have a name, it also has an ID. And what now happened is that while we removed the child role here on the workbook, MPS has no idea what the things we put into the workbook before are actually used for. One thing to fix this is to write migrations, which automatically migrate code of your language into a newer version of your language, because we have now done a breaking change, and we need to somehow get the existing code of our language or the existing code written with our language into a working state again. But I'm not going to take a look at this today because it was basically blow up the scope of the streaming episode today. We will take a look at that, but later in one of the later episodes, most probably shortly before Christmas, and then see how we can recover from this state in gracefully by writing migrations. But for now, I'm undoing this change here like this, and I'm not implementing the interface. Okay. As we can't easily just introduce a new child role at this stage without breaking existing code, what else do we have as a choice? The other choice is we define a new behavior method here. Interfaces can carry behavior methods, and these behavior methods are then implemented on the concrete implementations of the interface. And what we would like to have is we would like to have a method that allows us to return a sequence of statements. So all the statements that are available in the current context. And to do so, we define an abstract method on the interface, which is of type sequence of node statement. And I would just call it get statements. Okay. Now let's go back to our workbook. And when we implement the statement container interface now, we don't get an error message because of a bug in MPS. We need to define a behavior aspect first. So let's do that. Okay, now in my behavior of the workbook, I get the error message here that I have not implemented the get statements method. So let's do that. Press Command I and select get statements here. And now where are the statements located in this context? In this context, it's this, which is the current node, the workbook, and then the content of the workbook are the statements available in the current context. Let's do this. Make the language. And now we can do the same for the test case. But we implement the method in a different way, and we can, and I will show and afterwards we will then actually use our new statement container. Let's go to the test case. And first of all, implement the statement container interface, then create a behavior aspect. This. And then implement the missing method. And in this case, it's also the content we want to return here. So we select this content here as well. Okay. Now both of our languages have a way to return the statements available in the current context. And we need to use this in the variable reference scope here. Right now, it's hard-coded to look into a workbook. But what we are looking for is the ancestor that is a statement container, right? We are looking for the next statement container upwards in the AST. And then it has no content role anymore, but what it has now is a method called getStatements. Let's call this one. And then we basically do the same as before. We filter all the available statements to the variable declaration. We filter everything out from the statements that is not a variable. Let's rebuild. And go back to the workbook and see if this is still working. Can we reference X here? No, we can't. Wait a second. Ooh. Okay. We can reference X here. Plus. No, we can't plus because it's a Boolean. So let's select something else. Select C. plus y. Okay, this still works. Scoping for our variable references in the workbook works. Now let's take a look at tests if they work there as well. I have my variable y here, and I would like to reference x in the initializer. And if I type x, it also works. Nice. But what's not working is the case where we have no surrounding expression or variable. Let's put it like this. We are on an empty line here, and I would like to I would expect that I can now type some var here, and just like other expression statements, in the case where I press type 1 plus 2, it would be something that MPS would recognize and which I can directly use. But this is not working. Why is it not working? Let's take a look at the scope definition of the variable. So the documentation here says context node is the closest not null node in the AST. In the case where we have an empty line like this, and we type on it like this, what happens is that we have no. Let's take a look at the example where we have the variable var, and we reference foo here. Let's open the Node Explorer for the whole workbook and then navigate to the variable declaration of bar and look at the content so that you can see what's actually going on here. Okay, so this is the Node Explorer for the workbook. It shows the AST. And as expected, our workbook has a bunch of content. The individual variable declarations here, like C, Y, Z, X, etc. And then down here, our variable bar. Now, the value of it is foo, right? That's also correct. And the concept of the value is our variable reference. When we press Control Space here at this location, where are we in the AST? We are in the variable declaration here, and then in the value role of it. The value role is not initialized yet, so that node is null because we have not constructed the variable reference here yet. That means the closest not null node, the context node, in this case is the variable declaration bar here. If we look at the code, how we navigate up, so context node in this case is the variable declaration bar, and now we say give me the ancestor of this variable declaration that is a statement container. In this case, the statement container then is the parent of the variable declaration here bar, which is the workbook, because the workbook implements our interface. But in the case where we are on an empty line, what happens here? The variable reference is still not constructed, but so below bar, the next line in our AST here is this empty statement. If I now start typing on the empty statement, like bar, MPS will try to get the scope for the variable references. And what's now the nearest not null node? in this case, it's the yeah, okay. This case is a bit special. So in this case, we have defined a wrap. That means if we take a look at the expression statement here, the expression statement says you can type an expression everywhere where an expression statement is allowed, which also means at this location where we have the empty statement, we could replace it with an expression statement. But at that point, the expression statement is not existing. And MPS wants to replace the empty statement with something that is allowed in the current context. And what we would like to do is we would like to type a variable reference, which is an expression. But to be able to use it in this context, we would need to wrap the variable reference expression with an expression statement. And to do this, MPS would like to replace the empty statement that is currently in the position here in the AST. That also means the expression statement is not existing and the variable reference itself is not existing. And in this case, our scope here is invoked with the closest not null node in this case. As we want to replace the empty statement, the next thing that is not null in the AST is the actual workbook. And now our definition here says find an ancestor of the workbook that is a statement container. But if we take a look at the node explorer down here, there is no parent to the workbook that is a statement container. In fact, there is no parent at all for the workbook. What we want to tell to MPS is either look for an ancestor, or if the current node is already a statement container, just use that one. Because obviously we have a statement container, it's the workbook, but our code currently says, okay, use an ancestor of this node that is a statement container. One thing we could do is we could do something like this. We could check context node. Oops, context node is instance of, and then basically ask if it's a B statement container, and in that case use the context node directly, or in the other case just traverse the AST upwards to find the next statement container. But since this is a very common use case that you will encounter at many places in your languages, there is first class support for this in this ancestor call here. If we press comma here, so we can just add a comma at this location and then open the code completion menu, which allows us to define what's the context of this ancestor operations. And what we want to do is, so we want to use inclusion here. The others are rarely used. And inclusion means it's either the thing we are operating on, so the context node, or if it's not if this is not of the concept that we are looking for, then traverse upwards until you can find it. And this now, in that case, where we want to replace an empty statement, also gets us the workbook. Or hopefully. Take a look. Okay. And now it works. This is one thing you really need to get your head around, that with all the wrapping and other implicit things going on inside of MPS or with the code completion menu, you might end up in situations where while it seems obvious in the first place what to write here, it's not so obvious when the AST is going to be constructed. And this is why often including the inclusion in ancestor operations is important if you can, if there's no reason to not do it, because it saves you from a lot of places where wrapping is actually happening and the AST is not yet fully constructed to the level you expected. Yeah. Okay. There's also one thing that works here at the moment. And that is something I don't want to allow. And this is, for instance, yeah, and this. If we go here and we define a variable bar and we open the code completion menu, the first thing we see is that we could do this. We could initialize ourselves. Yeah, we could initialize the variable with itself. But there's also something else going on. There's things in scope that are not yet defined. We define our variable bar here, but x, for instance, is also in scope, and foo as well, and they are not yet defined. They are defined later in the program, and I don't want to allow that you can reference variables that have not that were not defined yet. How can we do that? Okay. One thing we could do is okay. So in the AST, when we open the Node Explorer here, we can see that these things are ordered in the way that we entered it in the editor. And what we want to allow to do is we would like to get the position in this content list here when we define our variable bar. We would like to know where we are in the list of content, and then we would like to only get the elements that are defined prior to us and not the variables that are defined later in the program. And we would need to do this in the scoping here to filter out the variables afterwards, right? One naive approach, at least for the variable case here, is to just look for the variable that we are defined in, or that we are currently defining, and then only look for the variables that are defined prior to us. How to get the position, we will take a look at this in a moment, but let's assume we have a way to get the position in the program of like the statement here, like the variable declaration. But in this case here, when we have a expression statement going on, we can also select everything from the code completion menu. And in this case, I also don't want to allow foo, bar, and x, I think. Yeah, these are the three variables that are not defined yet. What that means is we want, from the current context, we want to get all the variables that were defined prior to our current position. How can we do this? So let's take the context node and wait. So if we take a look at the parameters here, we can see that there is a is a parameter called position. And the documentation says, let me move this up a bit so that you can see it. The documentation here says simply it's the context node child position in role. Pretty complicated name for the index in the list of children. So in this case, it's the index, the position, the index in this contents list of the workbook that we would get here, if I'm not mistaken. No, it's context. Okay, so it's in the context node. Okay. Okay. So let's first do the simple case here where we have a context node available. In this case, we have a context node, and what we are looking for is the next statement. In this case, in the variable declaration, we are looking for the statement for the variable declaration for bar here, and want to get that position and only include all the variables prior to that. We can use the context node here and do an ancestor query again, just like we did for the statement container, but we are not looking for the statement container. We are now looking for the next statement. B statement. And we want to include the case where this is a statement context. Okay. Now we get the statement, which is our context in this case for the for the program here. And now we can ask this one for its index. And this index operation will contain, will return the index in this list of statements. In this case, the content list here. So for our case where we are here in the AST, press Ctrl space, then walk up until we find the next statement. In this case, it's the variable here. And now we take the index of this one. In this case, it would be 4, if I'm guessing correctly. And we want to use this index in the scope calculation here to filter out everything where the index is higher. After we filtered for only variable declarations, we can also try to filter it further. So let's add a where operation to this list. And as we did with the statement, we can get the index of the variable declarations here. Now we filter, we want to include all variables where the index is smaller than, let me rename this to statement index, where the index of the variable declaration is smaller than the index of our current statement in the program. Let's build this and go back to our workbook. Okay, so first thing we notice here is that bar is no longer in scope. We get an error message here that we cannot reference bar. If we open the code completion menu, what also happens is that we only see z, y, and z, because these are the variables that were defined prior to the position in the program. And y. And if we now move the statements here up and down in the AST, we can see that MPS automatically reevaluates these constraints for us. So now I moved the bar declaration before the Y declaration, and MPS checks for us that Y is no longer in scope. So we get the error checking here basically for free. One thing we cannot easily do is influence these error messages that are shown from the constraint check here. We have to stick with the generic error message that the reference to the variable Y is out of scope in this case. Okay. Now that works. Let's try if it also works. So let's try if it also works if there's nothing in the line here. So let me open. Yeah, and now we had this special case before where we need to handle where we were handling like the case where we are replacing an empty statement. So we had to do something something to handle this this edge case, and now we can. What we also see here is that now nothing shows up in code completion, and this is basically because we are facing a similar problem. In this case, we are replacing an existing statement. In this case, the empty statement. And in our scope implementation, we are looking for the next ancestor of type statement. But we are currently replacing a statement, and that means there is no statement we can walk up to. There's simply no statement yet defined that we can use as a context here. And first of all, we can detect that case, right? So in the case where we have no statement context, this query will return null. If statement context is null, so for all parts of the S model language here, all variables that are of type node something, they have a bunch of operators or operations that you can execute on them, and one is null or is not null. And in the case where the statement, let's do the easy one first. So in the case where we where the statement context is there, we want to use it and use this as the index to filter out the elements based on the position in the program. Let me split the declaration and assignment here. Okay. In case we have a context, statement context available, we use that statement context as the index to look for other statements. But in the case where we don't have that, what happens? In the case where we don't have a statement yet, we can take a look at the help here again. Position as an argument here looks quite promising, right? It somehow tells us the position in the program. But in case where the context node is something that is already initialized, like the variable declaration or other things, this position will basically always be 1 because it's the position inside of the context node. But in case where we don't have any context, where there is no statement created, etc., we get the position in the context node. And the context node in this case is the workbook, right? So we had to write this explicit inclusion operation here to handle the case where our context node is already the statement container, in this case, the workbook. That means the position here is the position in the list of statements on the workbook. And context equals position. And it complains that statement index. See what happens now. Back to the workbook here and press Control Space. Okay, what has happened is that it now works. Our code completion menu contains all the variables defined prior to the current position in the program here. Why does it work? Okay, as I mentioned before, we had to handle the case where there is no statement constructed yet, because we are in this case where we want to wrap something that that already exists, no, we want to wrap something that does not exist already. And in this case, our context node, the nearest thing in the model that is not null, is the statement container. Because the statement and everything is not yet constructed with all the wrapping going on in the code completion menu. The only context available to MPS to pass into this constraint calculation is the statement container. And we use the same kind of behavior here, that in the case where we could not find any statement as an ancestor, we need to assume that the statement is not yet constructed, but that MPS at least knows at which position the new statement will exist. In this case here, it passes the index of the empty statement that we want to replace as a position in here. And then we can use this position as the point in the program that we want to use as the index here. Okay. So this also works now, I guess, as expected. So we could type z plus y plus bar. Okay, that works. Okay. Does it also work in the case where we have tests? Let's take a look at it as well. Can I still type? Yes, I can still type some var here, even on an empty line. I can also I can also create new variables here. So let's create a new variable z and do x plus y. operation is not supported. Because it's a Boolean. Yeah, we are adding 2 Booleans here. Obviously, this makes no sense from the type system perspective. We can type that. And can we also type x equals y? Okay, we don't have a type system for that, I guess, at the moment. But at least we can reference this. Take a look at the types here. We have a Boolean and a Boolean. For some reason, our equals expression is not supporting that. Let me put this as a issue into the repository so that we don't forget it, because I don't want to look at it right now. Basically, create an issue here. I'm not logged in yet. Okay, I have to create the issue afterwards because I don't have the credentials here. Okay, let's do that later. Okay. What we did today is we added scopes for our variable references based on different contexts. It works in the test cases. It also works in the workbook. The constraint implementation is also reusable and I think reasonable generic at the moment. What we don't support yet is like nested scoping. For instance, I mean, we also don't have concepts for creating new scopes, right? So at the moment, the only thing we have here is the workbook that has a single scope here with all the variables and statements. And we have the tests where each test case is a new scope. We don't have anything that like opens a new scope. One idea here, what we could do is we could actually add some more control flow. For instance, adding if statements, and then we could have nested scopes there, because the if statement basically creates a second scope that is self-contained. Because I mean, we can just build an if statement now, but yeah, let's do that. Let's go to the statements here and add an if statement. It's a B statement. It needs an alias because we want to type if and then get the name here, get the entry in the code completion menu. And similar to the test case, we want to have an indent layout because we want to actually indent the part in the below the if. We want to have a constant if. Then okay, we haven't defined the actual content here. Okay, let's do a very simple if statement without else for now. First thing the if needs is like the condition, right? So each if statement has a condition which is evaluated, and the condition is not optional. And the condition is also an expression. You can type any arbitrary expression there. And then we have the then part, which is statement. Multiple statements, yeah. Okay, and the editor looks like if, then we can do an opening parenthesis, and then we want to show the condition, a closing parenthesis, and then an opening curly bracket, then the then part, and then a closing bracket. And now, just as before, we have to add these style attributes that there are line breaks. We want to add the add new line here. We want to have a new line after the curly bracket here. Then we want to indent the then part, and then we want to have the closing curly bracket here on the same indentation layer as the if. Okay, let's rebuild this. And let's go back to the workbook. The cases where I type if, I now get an if statement. And the if statement contains a bunch of more statements here. And you can give it a condition, 1 greater 2. Yeah, the editor still looks ugly. We still have to apply some styles there. But now we can add additional variables inside of the if statement here. And oh, if I press enter, okay, this is out of the editor definition. It's still on a single line. We want to change that. So the if statement here, and just as before, select add new line for children. And also want to have an element factory here so that we don't end up with these errors. Empty statement when the user presses enter. Let's make this again. Go back to the workbook. Now, if I press enter, I get an empty line for each time I press enter. I can also define new variables in here. Y plus inner x. But what happens now is our scope is oddly broken here. So it seems like some things aren't really working out here at the moment, right? I cannot reference inner x. The code completion menu only shows me z, which is strange because this is like the top position here. And this is because our scope here walks to the next statement container, right? But our if expression is definitely also a statement container. It should implement the interface here, statement container. And then we also need to implement a behavior method here. That's statements. And in this case, the statements that the container contains is not the content, but the then part of the if. Make this, go back to the workbook. Like this. Okay. So now inner x shows up in the code completion menu, but everything that we defined prior to the if isn't working. So the scopes aren't nesting. We are basically completely replacing that scope at the moment. So we can see that there's still some things missing for this particular case. And this would, so what we need to write for this is nested scoping, right? So in this case, we would like to include the scope from the workbook into the if statement. But we also might want to allow something like this, that we could shadow variables that were defined in the outer scope. In this case, it's our x here, which is an integer. And in the other case, we would have an x here that is a Boolean, which we also might want to allow. And for that, our scope implementation is way too primitive at the moment. We do not have any hiding going on here. We do not have any nesting going on. And we would need to do some major refactoring to our scope implementation here. But I won't do this today because this is quite a big refactoring, and in my time zone it's already 10 o'clock in the evening. So I would like to do this on Thursday at the next episode, and then take a look at how we can refactor this, how we can make the scopes more generic, and make them easier to compose. Because MPS also has integrated support for these kind of things, and we should make use of this as well. It allows you to define the scope a bit more declaratively in the actual constraint here, and then we can move the implementation to a more specific case, to a more specific place. Sorry, because otherwise we would implement quite a lot of code in here to handle all of these cases, and I would like to avoid that. And MPS has support for that. It's called scope providers. We will take a look at that in the next episode. After the I will now commit this into the repository. Let's do that. So we edit test language with asserts and test cases. We edit also variable references, and we edit a basic scope implementation for that. And we edit an if statement. Okay. And we commit that. Yes. Okay, and I can also push that now. Okay. So it's now on GitHub. As usual, you can find the code here on GitHub, and take a look at it yourself. In the next episode, we will take a look at the scope providers, and see how we can implement scope providers to make this the scope implementation more easy or easier, and also more generic. I am not sure what was on the actual. So let's take a look at the plan for the next episode from the original schedule. So we were at references and scopes today, and next time, yeah, we will also take a look at how we can actually test our languages. But before we do that, I would like to take a look at how we can implement the scopes in a better way. I have also updated the Google Calendar, by the way, with all the I mean, we used the buffer last time. Okay. Yeah, we will implement that next time. Feel free to join the discussion on Slack. We have a Slack channel here to provide feedback there and ideas. Also, just add comments or issues to the repository to give feedback or what you would like to see in the language later on. Yeah, I'm still quite confident that we can get the schedule working until Christmas. After Christmas and next year, we will have to see. I have quite a lot of business travel coming up at the beginning of the year, so I might not be able to stream a lot during January. At least 2 or 3 weeks I'm traveling. And There's also some news from the MPS side in general, which is the version. There's a new MPS release done today, I guess. It's 2018.3. So let's take a look at JetBrains website. com/yes. Here, if I'm not mistaken, yeah. So the new version was released today. I might do some kind of special episode on the new version of MPS and show you some of the new features. But I'm doing this as more spontaneous. So yeah, I might do it on the weekend if I find the time, and showcase some of the new features shipped with the update. And I would also update the project that we have here to the latest version, and show you how much or how to do this, and how much work it is to upgrade a simple project like this. Spoiler alert, it's not much work. Usually things go quite smooth there. Okay, that's it for today. Hope to see you next time again. Have a nice evening, and goodbye.